Okay, so hello everyone. So my name is Kevin Choi, and today I'll just give you guys like a brief lecture about algebra, and it's kind of a continuation of like last month's lecture by Woojun. Yeah, and let's dive into it right now. So today we're just going to do like mostly three things. First of all, I'm going to tell you guys about a really fundamental theorem in algebra. It's called the quadratic formula, and we're going to solve some like problems related to it. And then I'm going to tell you guys about the Vieta's formula. And then lastly, we're going to do a challenge problem. Okay, so let's start with the quadratic formula first. So what quadratic formula is that in the equation of ax squared plus bx plus c equals to 0, or a cannot be equal to 0 because when a equals to 0, then this won't be a quadratic equation and become a linear equation instead. And when both of these like conditions work, then x, which is the root, it will equal to minus b plus or minus square root of b squared minus 4ac over 2a. So this formula, most of the people learn this in Algebra 1. This means that this is a really significant and a really fundamental formula in algebra itself. Yeah, and this is the basically like the golden formula, and this can be solved to all of the quadratic equations if the coefficients are shown and a does not equal to 0. And it also helps to prove the Vieta's formula, which comes on the later skaters. And so I just quickly made a proof of this formula. So how x equals to this equation at the bottom. So first of all, I factored out a from the equation and then made a square by having x plus b over 2a squared. And then since I was trying to create a perfect square, I have to subtract b squared over 4a squared. And then this is what happens in the result. And then I added b squared minus 4ac over 4a on both sides. And I also divided by a, which makes x plus b over 2a squared equals to b squared minus 4ac over 4a squared. And then I square rooted this, and then don't forget one thing, but I have to implement plus or minus in this equation. And then I subtracted minus b over 2a so that this will result at the end. So let's just try solve like some problems. I'm not going to give you like a lot of time, but so I'm just going to give you about 60 seconds for these two problems because both problems are a very like not very hard questions. So yeah, I'll just give you like 60 seconds. And make sure to like you guys can like DM me the answers if you got it. Okay, so 1 minute passed. So I'll just like give a quick brief solutions to both of these problems. So the first question, it is a very simple question. So if we just use the quadratic formula, then for number 1, the answer is minus 3 plus square root of 2, and then For number 2, what I used is called a discriminant, which is this part, b squared minus 4ac. And this is used for how many roots could be there. So for example, if b squared minus 4ac is greater than 0, then there are two roots, two real roots. But if the value of b squared minus 4ac is less than 0, then there will be no real roots and only the two imaginary roots. But if b squared minus 4ac equals to 0, then yes, and then this will equal to, then there will be only one root because like this part will be completely off. And when we look at the problem, so it says that it only has one solution for x. So this makes that discriminant equals to 0. So what I did here is a squared minus 16a minus 80 equals to 0. And then this is I kind of implemented the Vieta's theorem here, but the problem is asking for like the sum of the roots. So the sum of the roots will equal to minus 16. So quadratic formulas are like very powerful, but it could it could be very simple as well, depending on like what kind of quadratic equation it is. And the formulas can be like directly used in competitions like AMC 8, AMC 10, AMC 10, or even AIME. Yeah, and there are also many applications to the quadratic formula. One of the main examples could be the Vieta's formula, which will be on the next slide. So now let's move into the Vieta's formula. So Vieta's formula is like, it's a formula that can relate the coefficients of a polynomials to the sums and products of the roots. So I'll just give an example, simple example, right under. So fx is a quadratic equation with a squared plus bx plus c. And then we can say that the sum of the two roots, because this quadratic equation only has two roots, the sum of those two roots equals to minus b over a, while the products of root 1 and root 2 equals c over a. And these things could be easily proved by the roots from the quadratic formula. And this is only for quadratic, but Vieta's formula, it could be used for any types of equation, even for like, for example, I have an x to the n power plus a n minus 1 x to the n minus 1 power, and then it sums up until a1x plus a0, and then this has n roots. So if we have the sum of the first n roots, this will equal to minus a n over 1 over a n, and if we multiply all the roots, it will equal to a0 over an. And this is very similar to this part here, minus b over a and c over a. And for the rest, you have to multiply like certain amounts for this to equal to this part right over here. Okay, so let's dive into the problems again. So I'll give you guys 80 seconds for this one. So if you guys got the answer, like you guys can like text me what you guys got. Yeah, so you guys got 80 seconds now. If you guys got the answer, you guys can like give me a DM that you guys got the answer. Okay, so let's go over the answer. So the answer overall is 31, and how you solve it is basically that you get the both sum and the products of the two roots. So by using the Vieta's formula, the sum of the two roots will equal to -5, while the product of the two roots equals to -3. And since we're finding x1's the sum of the two roots squared, we use this identity that x1 plus x2 squared minus 2 x1 x2 equals to x1 squared plus x2 squared. And yeah, and when we plug in numbers here, this would like overall equal to 31. Now let's move on to the second question. So I'll also give you 80 seconds for this one, and you guys can start solving this for now. If you guys get the answer, like please DM me. Okay, so 80 seconds passed, and I'll go over the solutions. So we also use this by using the Vieta's formula, and then we're finding the prop we're finding the value of q. So in this case, q equals to the product of these two here, a plus 1 over b and b plus 1 over a. And if we multiply this, this will equal to ab plus 1 squared over ab. And since a and b are the roots of this equation here, we can find that ab would equal to c over a, which equals to 2. And if we plug in 2, the answer would be 9 over 2. And the answer would be D. Now let's go over the challenge problem. It could be challenging for some people, but for others it could be relatively fine. And I'll give you 120 seconds for this one. Actually, I'll give you up to 3 minutes, but if we end it quickly, then I'll just go over the problems. Okay, so time is up, guys, and I'll go over the solutions for this problem. So I made the solution on paper. So it's asking for the value of a squared times 1 plus a squared plus b squared times 1 plus b squared times plus c squared plus times 1 plus c squared. And how I use this to solve it is that I divide this into two parts. So I divide this into a squared plus b squared plus c squared, and then the second part I divide into a to the 4th power plus b to the 4th power and c to the 4th power. And since this is a with this, so I found the sum of the three roots of px, and the sum would equal to -3, and then ab plus bc plus ca, which are like the sum of the products of the three roots equals to 4, and abc would equal to 8. And then I found the first part, a squared plus b squared plus c squared, by using this formula above, which is like a version of expansion. And by this, we found that a squared plus b squared plus c squared equals to 1. And secondly, we need to find the a to the 4th power plus b to the 4th power plus c to the 4th power. And then with this, then we need to find the value of a squared b squared plus b squared c squared plus c squared a squared. And so that was the most primary thing that we had to find. So I kind of used the same formula, but it's kind of different, except that it wasn't A and B and C, it was A, B, B, C, and C, A. So I used like the similar formula again here as the one here. And then with this, the value I got was 64. And then I multiplied this by 2, and then with this, I was able to find that a to the 4th power plus b to the 4th power plus c to the 4th power equals to -127. And since it is asking for this value here, I got that the answer is -126. There could be more solutions, like finding the roots and plugging it into the equation, but this would take a longer time than just finding by the Vieta's formula. And one other thing that we could possibly do is Newton's identity, but this is also like extension to the Vieta's formula, and this will be like this is pretty advanced technology too. So in the introduction of algebra part 2, we focus on the quadratic equation and the Vieta's formula, but there could be many more advanced extensions to these two concepts. And again, like algebra is one of the most fundamental materials for computational math, such as AMC, AME, or like beyond. And before I end this open school today, do you guys have like any questions? Since there's no equation, I'll just end this one, and thank you for listening to my open school today.